everybody, and welcome to another episode of Python for Programmers, a series of videos introducing the features of the Python language for people who already have experience of programming any language with different levels of experience. So we're now getting on to some of the more advanced features, and we may be touching on features that you might not have experienced in the languages that you know, but we shall continue on. So let me get my Python notebook up for you. Okay, here we are. So calling this episode being fully functional, and we're going to look in more details at the use of functions and ultimately methods. So let's go back to where we first introduced functions. We did it a long while ago. So we talked about making a function like this. So I will just copy what we had all that time ago in functions and put it in here by way of a comparison. So here we defined my function with parameters x and y to return x and y. So defining it again doesn't matter. It will just overwrite it. But in Python and in many other languages, functions are first-class objects, and so you can manipulate them unlike any other object, variable or type. So in particular, we could have a saved function, and we could put my function in it, and we could use the saved function just like we could have used the other function, and we could just run it here. And it should be able to calculate our value here, 9. That's rather slow to calculate 9. But we can do so much more with functions being first-class objects. So because we can use them like anything else, we can combine them with the other features of data structuring or comprehensions and things like that. So we can have a list of functions. And you can put various functions in the list. So why might you do that? Well, you might do something like that if you wanted to do like a jump vector or a branch vector that we might do in computer science. So we could print out a command, an instruction to the user. Which function do you want? And we could get a reply from the user like this, and it probably wants me to say console read line. Yeah. Oh, so I'm guessing now. We'll see what works. No, I'll just sort that out now. Yes, silly me, I thought I was working in C#. Yeah, and then I can type I want function 2. So now we know I want function 2. I can now use my jump vector so I can print the result that I obtain if I call a function from the list indicated by the int value of the reply. Now, hope it does the type conversion for me. So I want to say I want function 1. No, I'm making another. Oh, it's got a letter S. Doesn't know what list functions are. So I have got error 2 because they work. This is because we counted from 0. So I'm letting you see this live. So it should have executed my function, but I haven't put the brackets in. So I've taken the function and I've got to give it some things to add. So I can give it 1. And 2. Oh, I've given it 2 again. Right. But leaving the functions in there, if you're a programmer, it helps you see what's happening, what's functioning. So here I've made my jump table from 2 functions. I can read in, but actually I can do better than that. I could make that a dictionary or some kind of jump table. So if I use the dictionary function, if the person types they want function 1, they can get my function, and if they type the word 2, they can get the saved function of my jump table, and then I'll just steal the rest of the code for speed of explanation. So now I get the word. I don't need to convert it into an integer. I just use the word in the branch table, and so now I can type I want to use function 1, and it should select from but I haven't selected from jump table. So you're watching me debug code here. So it's being slow now. So it should print out which function. Let me just interrupt this cell for now. I'll just interrupt it and run again. I get which function, type 1, and it calls a function. Okay, now that basically, if you know any other languages, I've just shown you how to implement a switch case statement. But in low-level machine code, these are branch tables, jump tables, things like that. Right, so we're a bit slowed down by my silly typing and mistakes, but it helps you sort of see what's going on here. So we can actually make this better in that, say, we don't actually have to define a function, because those of you aware of many languages, we can have a thing called a lambda function. So our lambda function is an anonymous function. It doesn't have to have a name, so we can put it straight in the dictionary. And this has two arguments, A and B. And so we just have to quickly then after that put the colon in. Sorry, I lost my mouse temporarily. And the result of that is A plus B. And we should be able to then put another anonymous function for the dictionary empty2, which I shall do the same function. I'll try not to make the silly mistake so I did last time. I'm forgetting to change the table, so I should be able to run that, and I can type I want function number 1, and it obeys that anonymous or lambda function immediately, and I haven't had to use a def. And actually, by implication, using the def here is just a convenient shorthand for assigning that. So a function equals lambda of a comma b is equivalent to the definition of the function here. And those of you who know some languages, other languages allow both forms, anonymous function assigned to a variable, and the shorthand way, which is a traditional function definition, and one is just defined as a shorthand for the other. Okay, so we've covered lambda functions, we've covered functions as first class objects. What else shall we cover? Let's add a new cell. So some of you are thinking, what other features can we do with functions? So we can have variable length argument lists. So Python can do that. So if we go back to a function definition, so if I have a function called many, I can have some named arguments, and if I put a star, I say that's many, and actually it defines a tuple. So just to prove that, I can print the arguments. I can print first and other, and then I can print my call of many, and I can give it a string for A, and a string called B, and a string called C. So that should pick them up if I've got my syntax right. Yes, it does. So you see, it's A is matched to the first argument, and B and C are delivered as a tuple here. So that's not a list, it's a tuple. We also are allowed keyword arguments in Python. So I can define something and my argument 1, and what is used is 2, and it's not a requirement, but it's a convention that you call that keyword. And what that does is deliver you a dictionary. So I can print, and it's a dictionary sort of indexed by the keyword. So I could call with keys, I could give the first argument, and then I could say 1 equals 1, and then I could run that one, and it's selected from the dictionary that has been given the argument whose dictionary key matches that one is 1. And you can mix those two. The other rule is that the variable length argument must be the last one. You can't put it earlier. So fixed position ones followed by variable length, but you can tag on keywords as well. Okay, so that's more things that you can do with functions. So we've got a few more minutes to talk about functions, and I think the last thing we could do to finish off is to talk about generics and polymorphism. So one thing I've been saying is these arguments are not typed, they are polymorphic, so you can handle something with many types. But what if the code inside needed to know the type? So let's define a function, and the way of checking this in Python is to handle these generics. So we could say if A is an instance of a string, then we could print something that says I'm a string, and then perhaps we could then say else if A is an instance of an int, I could print that it's an int. And else I don't know what you are. Okay. So a kind of example. So now I'm going to call what type, and let's run that. Okay, let me just fix my type up. Just a second. Okay, actually the is instance is a function, so I should be saying A is instance of a string. That's what happens when you're thinking in too many languages at once. But I'm assuming that is similarly a phenomenon for you. So here we are, I've passed an integer, and it says an integer, but what if I passed it a complex? It should say that it's an unknown. Printf C plus functionality, and it says that's an unknown type. So that's the thing about an interpreted language. We don't debug all the errors until we execute all the branches. So you can see I was able to sort out the types of the generic if I wanted to. So we've got generic functions, they're polymorphic, they can have multiple numbers of arguments, they're first class objects, they can be embedded in data structures. You can use that to make junk tables and various other things. So that's a big chunk of material of the kind of things that you can do with functions in Python, and there's a few more things that you can do with methods in classes, but that will be something for another episode. So sorry about the distractions there, but I left them in because I thought that's useful. You'll make typical mistakes like that yourself as you go along, and it's useful for you to see. So thank you very much, and I'll see you in the next episode.